Today we are dividing polynomials. Let's begin by considering this polynomial function. And we see that it's a cubic. We could sketch the graph of it if we wanted to, right? So I'm just going to tell you that you can also factor this, and this polynomial factors into this polynomial. All right? So I know that these are the zeros of f. We did that last time. If these are the factors, then these are the zeros. And I could sketch the graph of this if I wanted to. All right? What happens if we divide by one of these factors? Let's say that we divide by x minus 1. What would happen to that, to this function if we did that? If we divide a polynomial by one of its factors, do they just cancel out? Can I cancel this out and say that this is equal to this? If I were to graph this and graph this, are they identical? Is this a true, did I write a true statement? And knee-jerk, I know what you want. I know you want to say yes, it is definitely a true statement. I'm going to tell you that no, it is not true. It is not true. This is not equal to that. It is equal, these are equal if x is not equal to 1. These are true if x is not equal to 1. If x is equal to 1, then this is not true. Because the graph, if we were to graph this, it would be a parabola, but it would have a hole in the graph. It would have a hole when x was 1. If I were to graph this, there is no hole. It's just the parabola. So they are very, very similar. They only differ when x is 1. All right? Okay, what happens if you try to divide a polynomial by something that is not one of its factors? Well, if that happens, then you get a remainder. Okay? So when we're dividing, a lot of times we do get a remainder. Once in a while we get a factor. We find that what we divided by was one of the factors, so we do not get any remainder. We get a remainder of 0. Okay, so division. Let's recall how we divided just whole numbers by hand, no calculator. Okay, let's divide 3,704 by 21. I'm going to come off the side and do this. So we divided 3,000, if we want to divide this, 3,704 divided by 21. Okay, by the way, 21 is called the divisor. The big number, the first one, is called the dividend. The dividend and the divisor, FYI. All right, so let's see. When we divided this by hand, what did we do? Well, I would say, if I were doing this, and I am, I would say, okay, 21 goes into 37. I'm not going to look at the entire thing. I'm only going to look at the first. I would begin by looking at the first number, but 21 is bigger than 3, so I would go to the second number. How many times does 21 go into 37? Well, only one time. And then I multiply those together, get 21. And then we subtracted this, right? And we subtracted that. So 7 minus 1 is 6. 3 minus 2 is 1, right? And then the way you probably learned it was you ask yourself, well, 21 better not go into 16. If so, then you got this number wrong. But I know that doesn't go into it, so I would bring down the next number and go through the same thing. Okay? How many times does 21 go into 160? I will tell you that for our purposes, since we're about to do this with polynomials, I'm also going to bring down that 4. So I bring down everything. Okay? So, but I am going to ask myself, how many times does 21 go into 160? Well, how many times does 21 go into 160? I'm going to try 5. No, it's going to be more than 5. 6 would be, nope, let's try 7. Let's try 7. 7 times 1 is 7. 7 times, yes, this is going to work. So 147. But it took me a second to figure out how many times 21 goes into 160, right? Okay, and now I subtract these two again. Okay. 10 minus 7 is 3, but I borrowed from the 6, so 5 minus 4 is 1. And 21 does not go into 13. That means we got the 7 correct. Okay, bring down this other 4 and do it again. How many times does 21 go into 134? Okay, 5 would be, 6 would be, is it 6? I want to try 6. I'm going to try 6. 6 and 120, I think that's right. Yeah? And then 14 minus 6 is 8, and I borrowed 1 from the 3, so my remainder, this was our remainder, true? We got a remainder of 8. I hope I did that right. Okay, so what happens when we divide this? We get 176. How do we write the remainder? When you first learned division, you would put like a big R and then 8. But we need to involve this divisor. We're saying that two things are equal. So this is 176 and 8 over 21. So these are equal. I hope these are equal. So let's see. Okay, yeah, they are equal. So 176 and 8/21 is the same as 3,704 divided by 21. Same thing. Okay? So we use a similar process to divide polynomials, and it's called long division. Okay? Just like this was called long division with whole numbers. All right? So I'm going to, let's see, grab another color. I'm going to take my dividend, and that's what the dividend is, what goes inside here. So I'm going to have, where should I put this? Over here. So x cubed minus 2x squared minus x plus 6. There's my dividend, and I divide it by my divisor like so. Okay. And just like we did here, how many times does x go into x cubed? What do I multiply x by to get x cubed? Well, I multiply x by x squared to get x cubed. So x squared is my first term in my answer, my quotient. So x squared times x is x cubed. X squared times negative 4 is negative 4x squared. Okay? And now I subtract. Subtract those two. So these subtract out. Negative 2x squared minus negative 4x squared is positive 2x squared. Bring down your negative x, bring down your 6. And do it again. What do I multiply x by to get 2x squared? Well, I multiplied x by 2x to get 2x squared. So that will give me the 2x squared, and then I have negative 8x. And now I subtract these. The x squareds are gone. Negative x minus negative 8x is positive 7x. And then I bring down my plus 6. What do I multiply x by to get 7x? I multiply x by 7 to get 7x. 7 times negative 4 is negative 28. One last subtraction here. 6 minus negative 28 is a positive 34. There are no x's, and I have an x here, so this is my remainder. And look at our polynomial up here. Once you get down to the constant, whatever's left is going to be the remainder. So this is x squared plus 2x plus 7 plus 34 divided by x minus 4. So again, new color here. So again, this is my dividend. This is my divisor. This is called the quotient. And this is called the remainder. Little terminology, a reminder for terminology there. Okay, let's do another one. Let's do this one. So I'm going to write out my dividend. And we are dividing by the divisor. Okay, what do I multiply x squared by to get 2x to the 4th? 2x squared. So this will be 2x to the 4th plus 4x cubed minus 4x squared. And I subtract these. This is gone, and this will give me a negative x squared. Bring down everything else. What do I multiply x squared by to get negative x squared? A negative 1. So go ahead and multiply out, and then subtract. Okay, we're going to get 5x, and then that's it. And the degree here is less than the degree here, so this is my remainder. As soon as your degrees, as soon as the degree here is less than the degree of the divisor, you know you're done. So this answer is 2x squared minus 1, that's the quotient, plus 5x over x squared plus 2x minus 2 is your remainder. Okay. Number 3. Okay. Let's see. We have x to the 5th plus 1 is my dividend, and I'm dividing by x squared plus 1. In class, I would ask you guys if these plus 1s cancel each other out. And you would say, no, definitely not. All right, how many times does x squared go into x to the 5th? What do you multiply x squared by to get x to the 5th? X cubed. So then we're going to have x to the 5th plus x cubed. And we subtract these. So be careful here, because this one definitely does not have any x's with it. So when you subtract these, you're going to get a negative x cubed plus 1. Now what do I multiply x squared by to get negative x cubed? A negative x. So we'll have a negative x cubed minus x. Subtract again. We're going to get a positive x plus 1. The degree is less than this degree, so I know this is my remainder, or part of the remainder. It goes with the remainder. And my quotient is x cubed minus x plus 1 over x squared plus 1. Okay, before we leave the sheet, I'm taking a quick look. I said some things are equal, and I want to make sure they are equal. Up here when we said this, are these two equal? Are these two equal? Yes, they are, because, well, they are, and x cannot be 4 again. Okay? For these two, I'm looking at these two, and these denominators can never be 0, so I'm not going to make any qualification for those. Alrighty. Okay. When you learned to divide whole numbers, you hopefully learned a quicker way to divide if your divisor is a single digit. Hopefully when you divided these, you learned a quicker way to do that. Each year I get kids who did not learn a quicker way to do that, so I reteach it quickly because it doesn't take long. So if you do this, if you have a single digit in the denominator, you really don't have to do long division. Okay, instead, you can do a shorter way, a shorter division. I'm going to take the dividend again. I'm going to set it up the same way, but you'll notice I'm leaving some space in between there. There's a reason for that space, and I'm dividing by 4. Okay, how many times does 4 go into 9? Well, twice. What's the remainder? When you divide 4 into 9, what's your remainder? Your remainder is a 1, right? 2 times 4 is 8, and then you need 1 more to make 9. That 1 remainder I'm going to put up here with the 3, and now that 3 became a 13. How many times does 4 go into 13? 3. With what remainder? 1. Because 3 times 4 is 12, you have a remainder of 1. Now we have the 4 goes into 18. 4 goes into 18 4 times with 2 left over. 4 goes into 24 6 times with nothing left over. 4 goes into 5 once with 1 left over. 4 goes into 11 twice with 3 left over. So this is equal to 2, 3, 4, 6, 1, 2, and 3/4. Those are the same thing. So that's a quicker way to divide. Okay? We also have a quicker way to divide polynomials if the degree is 1. Not if you have a single digit, but if your degree is 1. So if the degree down here is 1, you can use synthetic division. And here's how synthetic division works. Again, I'm going to put this here, but I'm only going to put the coefficients. And with synthetic division, it is crucial if you have a term that's missing. If you have a 0 coefficient term, you need to put a 0 in here. So I'm putting a 1 for the x cubed, I'm putting a -2 for the x squared, a -1 for the x, and a 6 for the constant. If you have 4 numbers here, you should have a cube here, and we do. Okay? And then for the divisor is x minus 4. I'm going to put what value of x makes this 0. What value of x makes that 0, that's what you put over here in synthetic division. Okay? Alrighty. Draw a line a bit. We're going to be putting numbers here, so draw a line below where those numbers will go. And now you're ready to begin to divide. So you begin by bringing down this 1, bring down the first coefficient, and now you multiply these together. 4 times 1 is 4. And now we're going to add. We're going to add these. So when you add these, you get 2. And then multiply again, and add. Multiply again, and add. Your very last thing is your part of your remainder. Oops. That's your remainder. You started with a cubic term and you took out an x. This is 1x squared. This is 2x, and this is your constant of 7. So your quotient is x squared plus 2x plus 7, and your remainder is 34 over x minus 4. And remember that your domain does not include 4 here, so x is not equal to 4. Okay? And that's synthetic division. Kids always say, why do you take the opposite of it? Take the opposite of it is similar to, and taking the opposite and adding here is similar to keeping it the same and subtracting. All right? You can think of it that way. Okay? So if we made this a -4, then we would be subtracting instead of adding to get each thing. But it's easier for us to add, so Take the opposite here and it takes care of that subtraction. Let's do another one. Okay, I purposely made this into a different order just to remind us to be careful. Okay, so what's going to go in the box? What's going to go in the box here? A -1 is going to go in the box. Okay, and now go to your highest degree term. -2 is your coefficient of the x to the 4th. We have a 1 for the x cubed, a -2 for the x squared. We're missing the x term, so I'm going to put a 0 for the x term, and then a 5 for the constant. It's a 4th degree term, so we should have 5 numbers for our coefficients, and we do. Draw a line a little bit below there. Bring down your first number, multiply, and add. Multiply, and add. Multiply, and add. Multiply, and add. We got a remainder of 0. We got a remainder of 0. What does that mean? That means that x plus 1 is a factor of that polynomial. Okay? The quotient is -2x to the 3rd plus 3x squared minus 5x plus 5. And that is true if x is not equal to -1. Okay? Alrighty, the remainder theorem. If a polynomial f is divided by x minus k, then the remainder is f of k. This is awesome. This is awesome. That means that right here, this polynomial, if I wanted to find out what f of 4 is, if that was f and I wanted f of 4, all I would have to do is look at the remainder. F of 4 is 34. I don't have to cube 4 and subtract 2 times 16 plus 4. I don't have to do all that work. All I have to do is look at the remainder. So if I give you a polynomial and ask you to find a value of the function, you have 2 ways to do that. You could, there's nothing wrong with putting -4 in for every x and cranking it out. It's just quicker, it's far quicker to use synthetic division to find that value. So we're finding h of -2, so -2 goes in that box. And then I have all these values. I'm going to put a 0 for my x term again. 4th degree, 5 numbers across. Okay, let's find our value of f of -2. Bring down 4, multiply, and add. Multiply, and add. Multiply, and add. Multiply, and add. H of -2 is 240. I'm going to want to prove that to you because I know you're doubting it. Maybe you're not doubting it. Okay, I'm going to, let's go into our, let's put this in for y1. So 4x to the 4th minus 16x cubed plus 7x squared plus 20. So that went in for y1, and then on my home screen I'm going to find y1 at -2, 240. Is that awesome? Okay, let's do another one. This is g. Find g of -2/3. So I'm putting -2/3 into the box. 15, 10, -6, another 0, and 4. Okay, bring down your first number. -2/3 times 15. In my mind, 3 goes into 15 5 times, so the 3's cancel out and we just have 5 times negative 2 is negative 10. 2/3 of 15 is 10. Okay? Add, multiply, it's easy to multiply that one. Add, multiply. 3 goes into 6 twice, and negative 2 times negative 2 is positive 4. Add, and now multiply. 3 doesn't go into 4 evenly, so we'll just have negative 8 over 3 there. Okay, 4 times 2 is 8. Okay, 4 is 12/3. 12/3 minus 8/3 is 4/3. So g of negative 2/3 is 4/3. That was far, far, far easier than putting negative 2/3 in for x and cranking it out that way. Okay? All right. One more theorem, the factor theorem. Okay? The polynomial has this as a factor if the remainder is 0. If f of k is 0, which means the remainder is 0. Makes sense. Show that this is a factor of f. So I'm putting negative 2 into the box to take care of the x plus 2, and I'm putting my coefficients down. So 8, negative 14, negative 71, negative 10, and 24. Alrighty, bring down 8, multiply, add, multiply, add, multiply, add, multiply, and add. Okay, f of negative 2 is 0. Therefore, x plus 2 is a factor of f. QED. Okay, and that's it for synthetic and long division of polynomials.